Okay, more on TVS. I'll do a couple more examples. This is great, but it doesn't work if you've got an expanded octet. So SO4, it wouldn't work. Okay. Let's do an example. NO3, 1 minus. Nitrogen is on the second row, so it can't expand its octet. So total. Nitrogen wants 8. Oxygen wants 8, and there are 3 of them. So 24 total. So total, 32 electrons that are desired. Valence, nitrogen brings 5. Oxygen brings 6 times 3, 18. 3 because of our formula. And you have to add in the 1 electron for the negative charge. This negative charge. So, total valence, 24 electrons. If you ever get an odd number of valence electrons, you did something wrong. You should always have even. So the difference here is 8. So if you divide that by 2 for 2 electrons per bond, we've got a total of 4 bonds. Nitrogen is our central atom. We only have 3 atoms. So because we've got 4 bonds, one of them has to be a double bond. So we know we've got 4 bonds in our structure. So 2, 4, 6, 8. I've used 8 electrons. I had 24. So now I have 16 electrons left. Start by placing them around the outside. So this oxygen needs 2 more. So that's 4, so that leaves me with 12. This oxygen needs 6. This oxygen needs 6. I've used up all of my valence electrons now. I've used 8, another 8, and another 8. So 3 times 8 is 24. I've used up all of my valence electrons. So this is my Lewis structure. Carbonate. CO3, 2 minus. TVS. Carbon wants 8. Oxygen wants 8, and there's 3 of them. Total of 32 electrons. Valence, carbon brings 4. Each oxygen brings 6. There's 3 of them for 18. Plus 2 for the negative charge, so 24. So the amount of electrons shared will be 8. So again, 4 bonds. Carbon is my central atom. It's got the highest combining capacity. I've got 3 oxygens. I need another bond, so I'm going to put in a double bond. Now I've used my 4. So I've used 8. I had 24. Now I have 16 left to place. 2, 4, 6. That makes 8. Around that oxygen, another 4 makes 8 around that oxygen. So I've used 10, another 6 here, gives me 8 around that oxygen, so I've got, oops, I've got 8, 16, 24 electrons used. This octet is full, this octet, this octet, this octet. So every one of them is surrounded by the correct number, and I need a 2 negative charge. C2H5OH. TVS. Carbon wants 8. There's 2 of them. So 16 wanted. Hydrogen, there's 6 hydrogens. Each wants 2, so 6 times 2 is 12. Oxygen wants 8, and there's 1 of them. So total here is 36. Valence, carbon brings 4, there's 2 of them, so 8. Hydrogen brings 1, and there's 6 of them. Oxygen brings 6, so my total valence is 20. So that means difference is 16. I need 8 bonds in my structure. Carbon is going to have 4 bonds. I have to stick hydrogens on the outside. So that means this has to be bonded to another carbon. I can't put an H there because it can't bond to anything else. That would be the end of my structure. So carbon bonds to 4 atoms. So 1, 2, 3, 4, 5, 6, 7. I've used 7 bonds. Here's my 8. So let's see how many electrons I've placed. 2, 4, 6, 8, 10, 12, 14, 16. So I've used 16 electrons. I had 20 to start, so I'm left with 4. 1, 2, 3, 4. Now, every atom that wants 8 has 8 around it, and all the hydrogens have 2. There's your structure. So TVS is great for your elements that are on the second row of the periodic table. Where TVS doesn't work so well is if your third row periodic table has more bonds than its combining capacity. So let's say, take a look at phosphorus. You can have PCl3, you can have PCl5. The combining capacity of phosphorus is 3. So this has 3 bonds. So TVS should work for this one and not for this one. So TVS, phosphorus wants 8, chlorine wants 8, and there's 3 of them. So 8, 16, 24. So a total of 32. Valence, phosphorus brings 5. Chlorine brings 7. There's 3 of them, so 21. So we've got a total of 26 electrons. So the difference, the shared, is 6 shared or 3 bonds. Three bonds. So now I've used 6 electrons. I had 26 valence. So now I need to place the rest of my valence electrons. So I've got 26 to place. Start with chlorine. Each one has 2. They want 8. So each one gets 6 more. So I had 20. I've now used 6 times 3, 18. I've got 2 left. Go there. So now I'll show you how I did that. So we had 26 valence electrons. I used up 6 for the bonds, left 20. Each chlorine got 3 lone pairs, so each chlorine got 6 more. There's 3 of them, for a total of 18, left 2. I was free to put them on phosphorus. So now everybody's got 8 electrons. Okay, PCl5. TVS. Phosphorus wants 8. Chlorine wants 8, and there's 5 of them. So we want a total of 48. Valence. Phosphorus brings 5. Chlorine brings 7, and there are 5 of them. 7 times 5 is 35. So this says I've got 8 electrons, which means 4 bonds. But clearly, I need 5 bonds because I've got 5 atoms of chlorine, which need to be bonded. So it doesn't matter if I've got 5 attached to phosphorus or 4 attached to phosphorus and 1 chlorine's attached to another chlorine. It still isn't going to work because I can only place 4 bonding pairs. So, cannot use TVS. And this is where you're going to figure it out that you can't do it using TVS. If I don't get enough bonds for the number of atoms on my central atom, if I don't have enough, then it's not going to work. Sulfate. If I did TVS here, sulfur wants 8, oxygen wants 8 times 4, 32, for a total of 40. Valence, 6. 6 times 4 plus 2. So that's 32. So the shared would be 8, which is 4 bonds. So that would say I could only have 4 bonds in my structure. But we know, because we did formal charges already, we know that that's not the correct structure. We know that we actually need 6 bonds. So TVS doesn't work for sulfate.